Good evening and welcome to the first lesson of Chapter 10. In tonight's lesson, we look at the area of parallelograms. So our objectives, you're going to be able to find the area of rectangles, and you're also going to be able to find the area of parallelograms. So we're going to go ahead and get started. First, what is area? When we talk about area, it's the number of square units, meaning a 1 by 1, so 1 square unit, that it takes to cover a figure. So for example, I have this rectangle here, which is considered a parallelogram, that they say is 8 inches by 3 inches. So if I wanted to, I should be able to fit in these square inches. And as you notice, about 3 of them fit along the width, and then 8 should fit along the side. So 3, 4, 5, 6, 7, and 8. I was a little too close in some of those. Alright, but you get the general idea. So that it goes 8 along and then 3 across. So if I filled this in, I'd have, well, 3 groups of 8. So 8, 16, 24. So this would fit in 24 of those square inches. That would be my answer. Alright, so you could fill in these little 1 by 1 squares if you wanted to, or you can use the formula, which is right here. The area of how to find a rectangle is you take the base, usually the length, and times it by the height. So, here we have this one. Alright, and it says find the area of this rectangle. However, first things first, we need to stop and make sure that we can multiply these numbers together. I have here for a length of 4 meters. And then I have 150 centimeters as the width. Well, that doesn't quite work because I have 2 different units. So the first thing I actually have to do is change the units. Alright, so we must make sure the units are the same. And there's a few different ways to do this. I could switch from meters to centimeters or centimeters to meters. Either way, you're going to have a right answer. So I need to know how many centimeters, which centa, there are 100 centimeters in 1 meter. So, one thing I could do is, well, I could say 4 meters. Well, that would be the same as 400 centimeters. So now I can multiply it together. I just now do the length, so 400 centimeters times 150. And I'm going to, I think, do it like, nope, I got it. All right, there we go. And if I multiply that, well, 20 and 6, and then add on my 3 zeros at the end, I get 60,000 centimeters squared. And you notice the units get squared as well. So a centimeter times a centimeter is centimeters squared. That's one way you could have done it. Or, if you wanted to, you could have kept the meters the same and said, well, if there are 100 centimeters in 1 meter and I have 150, well, that would be 1 5/10 meters. So then you would have done 1 5/10 meters times 4. And then move my decimal over, and I get 6. So my answer would be 6 meters squared. There we go. So either answer is the same. All right, so here you'd either get 60,000 centimeters squared or 6 meters squared. Let's try another. So again, make sure your units are the same and find this area. And I'm going to have you do this one, but I'm going to give you this hint. I know there are 3 feet per yard. Alright, so now it's your turn. Go ahead and convert the units of 1, and when you're all done, come back and check the answer. So go ahead and pause me now. Alright, let's go ahead and get started on this one. Now again, your answer may be different compared to how you do it. Me, I'm going to switch yards to feet. I know 2 yards is the same as 6 feet. So now I do 6 feet times 2 feet, and I have 12 feet squared. And there we go. That would be our answer. And again, you could have done, let's see, 2 feet and switch that to yards. And it would really be 2/3 of a foot, or 0.666, so on, times 2, and you'd have it in yards. So now we're going to move on to area of parallelograms. But what I have up here first is really 2 different note cards. Alright, so we're going to consider this a note card. And most note cards you get are 3 inches by 5 inches. and it's a rectangle. So I can tell you to find the area of this. And you do what we've been doing. 3 inches times 5 inches, the length and the width, and you get 15 inches squared. Now, I'm going to do something that might seem totally crazy, but what you could do is take a scissors and cut right along that line. Alright, so I'm cutting that piece off that triangle. So we're going to move over to the second one now. So I cut, there we go, I cut that off. Okay, so it's away from it. But let's say I put it up here. Alright, so I put it here. Would my area change? Alright, I know this is still 3 inches, but before we talked about that whole thing with the triangle being 15 inches. So I could place this triangle up here, or hey, how about if I place it right there? And then my 3 inches is still there, that height. And I'd still say my area has not changed because all I did was move that triangle. So the area of this is still 15 inches squared. Right? So when we do parallelograms, again, it's just 2 sets of parallel lines. All they can really do, or all they really do here, is move the triangle over to the other side. So to do this, you find the area the exact same way. You do area of the base, or excuse me, the area is equal to the base. So here, that 5 inches, and then times that, instead of calling it height this time, we call it the altitude. Alright, so instead of saying the height, which really is still 3, we call it the altitude. So we do 5 inches times the altitude, and you get 15 inches squared. Just to let you know, there are going to be some examples where they're going to say something like, oh, this is 6 inches right here. Now, you want to use the straight line that is perpendicular to the base. So this 3 as the altitude instead of the 6. Because this is not a straight line, so it's not actually the height, straight up and down. So here we have this one. Again, let's do A together, then I'll leave you to do B. Alright, so I have my parallelogram here. I'm looking, my base, the length of this long side here is 8. So my length is 8 meters, and now I have to find the height. And I have 2 options. I could use this 2 meters or this 3. But again, if you were just listening to what I said, the altitude, it's always the one perpendicular to the base. Oh, this is where they meet up. And look at that, they give you a nice little right angle to let you know it's perpendicular to it. So you take that 2 meters, and you get 16 meters squared. All right, now it's your turn. I want you to do B, and when you're all done, come back and check your answer. So go ahead and pause me now. All right, let's go ahead and try B. Well, my base here is still 6 inches, and my height, or I'm sorry, you could think of this as a base as well, 2 5/10, and then if you go outwards, the altitude is still 6. So 2 5/10 inches times 6, and I get 15.0, which is just really 15 inches squared. There we go. Alright, so that's your lesson for tonight. Tonight we talked about how to find the area of rectangles by just doing the base times the height. And we also talked about how to find the area of a parallelogram, which is the same idea. Find the area of that base and then times it by the altitude, or another name is the height. So have a great night, and I will see you all in class tomorrow. Adios!